All right, let's have a look at question 2e. This is the last of the number 2 questions from the 2012 NCEA final exam. It says the width of a canal at the ground is 16 metres. So this is the ground level, so we know that from here to here is 16 across. Next we're told, it says the size of the canal can be modelled by a quadratic expression that would give a maximum depth of 16 metres. So I assume it means the whole thing there is going to be 16. So the whole thing there is going to be 16 from the base right through to the turning point here. It says, however, the base of the canal is flat with a width of 12. So that's interesting. So what it's saying here is it's making a distinction between the base, which is there, and the maximum depth, which must be different then. And so that would make sense for this to be 16 meters and the base to be something a bit different. So that works quite well. So it says, what is the actual depth of the canal? So it's wanting the actual depth, in other words, the base. In other words, from the top to the bottom, how far is this? I'm just going to put an X question mark with an arrow in there somewhere. So we're going to find that. So first of all, let's model the parabola. And there's so many different ways we can do this. And just to give you an example, there's no reason why we couldn't have, and I'll just throw a few examples of this. Let's say, for example, you could have one that looks like this. Turning point here, yeah? And somewhere along here is the base. This is the base bit here. And at the top here, you've got the ground level bit here. And you're going to find the distance from here to here. You could do that. And this being, of course, your 0 point. This, of course, is your x-axis. And this, of course, is your y-axis. You could do it that way. Another way, which would work probably quite well, is to have the x-axis, say, here. And then make that 0. And then have this is going to come out over here. And it's going to end up being like this. In this case, by the way, this would be 16. This here would be a 16 here. And this here, you could do it differently again. You could have it heading down. Another quite a good way would be to have the top here. This is the 0 point. Now here's your x-axis. Here's your x-axis. Here's y. Here's y. Here's your y. But what you're going to do now is have it going like this. Yeah, have it going around. Having this be negative 16, have this being 0, and so on, yes? So you could, the 0 being that this is the y equals 0 line, yeah? So you could do it that way. I'm going to choose to do it the top way. I think I'm just going to do this, just do this. So let's just draw that up a little bit more precisely. So we're adding a few more details, I think. So here we go. This is my 0. Here's my x. This is my y. It's going to head down like this. It's going to turn there, head back up. This point here is going to be, and we want to find, well, we know it's 16 across, which means it must be 8 this way and 8 that way. So that must be 8. And this point here, which is heading up here, this must be negative 8, yeah? What else do we know about this? We know this has, so therefore that would be 16 across the top there, and that would be fine. The base is at 12, so we want to find, well, 12 would mean 6 either way, so if it was 12, then it would be like here, yeah? So this would be 6, this would be negative 6, and of course the distance from there to there is going to be 12. So whatever distance, whatever position there is what we want to find, because if we know that, then we can find the distance from here to here. Yeah, and that's really what we're trying to find. So let's go ahead and do that. So first of all, we can actually draw up a few things here. We know that y is equal to a, and we can just do the general form for x minus b all squared plus c. So let's have a look. So y, let's throw in some coordinates here. This is going to be 8 along and 16. Yeah, this would be negative 8 and 16. I'm just going to use this one here. So let's throw in some numbers here. Well, this has moved 0 up and down, so C must be 0. B must be 0 because it's moved up and down 0. We've got an x squared. I'll put a plus here. It doesn't matter anymore what that would be. So y is equal to that. Let's populate this now with our values. So we've got an x of 8 and a y is 16. So 16 is equal to a. Now we've got x. Now x we decided was an 8. 8 plus 0 all squared. So that's going to be 64a is equal to 16. So dividing both by 64. What do we end up? So 64. So a is equal to 1/4. So now we've got an equation. We've got y is equal to 1/4 x squared. So there's our parabola. And of course, what we're wanting to find is y. That's how far up this is here. We want the y value when x is 6. So let's try that. So the y when x is 6, 1/4 times 6 squared. So 1/4 of 6 is 36. So y equals 36 on 4. So y would equal 9. Of course, that's not the depth. That just happens to be the coordinate here. So we know this coordinate here, for example, is going to be 6 along and 9 up. Of course, that's 9 at this point here. So we're 9. The question now is how far is it from here to here? Well, if that's 16 and that's 9, we're going to this point here is going to be 16 minus 9, which is 7. So we can say, therefore, height or depth, what's it asking for? It's saying the depth. It's saying, therefore, depth is equal to the height, which is 16, minus this point here, which you know is 9, whereas this is 16, so 16 here, 9 here. 16 minus 9 is equal to 7. I'll write the units in, and the answer is going to be 7 meters. So that's how I would solve that. Hopefully that makes sense.